able to work out the diameters here of these 4 squares. The first square is 1 centimeter long and 1 centimeter high. So if we're going to work out our formula using Pythagoras, c squared is a squared plus b squared, where our c squared here is the red hypotenuse. Okay, so it equals 1 squared plus 1 squared, which is the same as 1 plus 1, which equals 2. So c squared, the hypotenuse of our first triangle, is 2. So c, the length of our hypotenuse, is the square root of 2. The square root of 2 can also be written as 1 times the square root of 2. There's a reason I'm doing this, and we'll show you that later. Let's move over to c2. So here we have the hypotenuse, c2 squared, that we're wait a minute, we're just trying to find out c2 first. We're trying to work out the length of the hypotenuse c2. c2 squared is the same as 2 squared, a squared plus b squared plus 2 squared. 2 squared is 4 plus 2 squared is 4. So c squared, c2 squared, is 8. So that c2, the hypotenuse for the square that's 2 centimeters long, must be the square root of 8. That's the length. We can rewrite the square root of 8 as being the square root of 2 times the square root of 4, because 2, using our surd technique, multiplying square roots like this, 2 times 4 is 8, so we can rewrite the square root of 8 as being the square root of 2 times the square root of 4. The square root of 4 actually is the same as 2, is it not? So that is the same as 2 multiplied by the square root of 2. We've got the 2 here from the fact that we know that the square root of 4 is 2. So the square root, so c2 is the same as 2 times root 2. And now we investigate what happens with the third square. So here, when we had a square that was 1 centimeter long, we got the answer that c was, c1 in this case, was 1 times the square root of 2. When the square was 2 centimeters on each side, we got the answer as being 2 times the square root of 2. So before we even do anything here, if we try and think smartly, what would we expect for the third square? Well, I would expect the answer to c3 to be, my square is 3 centimeters long. I would expect it to be 3 times the square root of 2. Let me see if it's right. c3 squared equals 3 squared plus 3 squared. 3 squared is 9, plus 3 squared again, 9, equals 18. c3 then must be the square root of 18, because c3 squared equals 18. The square root of 18 can be written as the square root of 2 times the square root of 9. Square root of 9 I know is 3, so it can be written as 3 times the square root of 2. Ah, that was what I was expecting it to be. So what am I going to expect, what am I going to get as an answer here then, for a square that's 4 by 4 centimeters? I'm expecting c4 to equal 4 times the square root of 2. Let's just do it. c4 squared is going to be 4 squared plus 4 squared. So this is c4. It's going to be 16 plus 16, which is the same as 16 times 2. Yeah. And c4 then if C4 squared is the same as 16 times 2, C4 must be the square root of 16 times 2. I'm writing it a different way here because it actually makes a lot of sense to keep it as the number times 2. Because we know that the square root of 16 is 4. So we can take that outside already. The square root of 16 is 4 multiplied by root 2. 4 times root 2 was the answer that I would have expected. Okay? So what they're trying to show you here when it comes to squares is that the hypotenuse of a square is always going to be whatever the length of the side was multiplied by root 2. It was that here. The side was 1 centimetre multiplied by root 2. The second square, the side was 2 centimetres. The answer was 2 multiplied by root 2. The side of the third square was 3 multiplied by root 2. The side of the square with 4 centimetres on the side was 4 multiplied by root 2. So they want to introduce this concept to you of what happens with square. So without even having done the calculation, if I have a square here that is 9 centimetres by 9 centimetres, what will the length of the hypotenuse, the diagonal on the square, it's the hypotenuse of the triangle or the diagonal of the, what answer would you expect it to be? Let's call it C9. C9, what answer would you expect it to be? How long was the side of the square? 9. Multiplied by root 2. We would expect it to be 9 times root 2. Okay, let's prove to ourselves that it is, because now we understand what happens with squares. To get the length of the diagonal in a square, we take the length of the side and multiply it by root 2. 9 squared is 81. So C9 squared is going to be the same as 81 plus 81, which is the same as 81 times 2. So C9 must be the square root of 81 times 2, which is the same as the square root of 81 times the square root of 2. The square root of 81 is 9, and we can't simplify the square root of 2 anymore. So yes, we're using our maths to prove it. So this is a very important technique that they want you to understand, how to get the length of a diagonal for the size of a square.